So here we are at number 41, and you can see in 41 that we have two individual terms on the top and two on the bottom, so I can't just invert and multiply. So let's use the general procedure for this one. We know that is to get the LCD first, so let's get the LCD. So we're going to have that z minus 1. We'll have this z plus 2. Now it appears 2 times, but to the first power in each case. So we're going to have the z plus 2, and we've also got this z minus 4, so let's get that one, z minus 4. So this is going to look a little bit long when we draw it. You know what to do here. We're going to put this LCD alongside each original term. So we'll put all of this right here, right here, right here, and right here. So let's do it. It's just going to be a little bit long. So we'll get 1 over z minus 1 times z minus 1, z plus 2, z minus 4, plus, right, that plus sign right there, and then this 2 over z plus 2, 2 over z plus 2 times, and then we'll put the LCD right alongside, so it'll look like this, z minus 1, z plus 2, z minus 4. And all of this goes over. All right, now these denominators should cancel. That z minus 1 is going to go out with that one. The z plus 2 over here is going to go out with that one. That z plus 2 will go with that one. And this z minus 4 will go out with that one. So let's do all that. Let's cancel those. So we're going to get this z minus 1 going out with that one. And if we do that, we are left with 1 times z plus 2 z minus 4, which is just z minus 2 z minus 4. Oh, I didn't change colors again. That's okay. Plus, now over here, that z plus 2 goes with that one. We're left with 2 times z minus 1 z minus 4. So let's write that. 2 z minus 1 z minus 4. And in the denominator, this z plus 2 will cancel with that one, so we'll have 3, this z plus 2 with that z plus 2. So we'll have 3 times z minus 1, z minus 4. So we're going to have 3 times z minus 1, z minus 4, minus, and now in this last term over here, that z minus 4 is going to cancel with that one, and we're left with that 2 times z minus 1, z plus 2. So we're going to have 2 times that z minus 1, z plus 2. Now, let's make these multiplications. So I'm going to start here. We'll get z squared, negative 4z minus 2z, negative 6z, and then plus 8. So let's write it. I'll do it up here at the top, change back to colors. So it's going to be z squared minus 6z plus 8 plus, now here's how I'm going to do this one here. I've got a constant times those two binomials. I'm going to do the binomials first, then I'll take the constant in. So it's going to be, I'm going to write it as 2 times, now let's multiply this out. So we'll get z squared minus 4z minus z is minus 5z, and then the outer product plus 4. So let's write it. So we're going to have z squared minus 5z plus 4. And in our denominator, we're going to have a 3, and then I'll multiply those together. Now, we just happen to have done that one. That's the z squared minus 5z plus 4 minus, now let's write this 2 here, and I'll multiply these out, right? We're going to multiply these together. So I'll get z squared, 2z minus z is plus z minus 2. So let's write that. So we're going to get that 2 times z squared plus z minus 2. All right, let's finish our multiplication here. So we're going to get z squared minus 6z plus 8. Now, let's multiply through by 2, right? Distribute. So that 2 will go to each one of those terms. So we'll get plus 2z squared minus 10z plus 8. And in the denominator, Let's take this 3 through, so multiply everything through here by 3. We'll get 3z squared minus 15z plus 12. And over here, we'll take the negative 2 through. So we'll get minus 2z squared minus 2z, and then negative 2 times negative 2 is going to be a plus 4. So let's combine these terms on the top. We'll have a z squared plus 2z squared. So that looks like 3 of them. So we'll get 3 z squareds. And then what do we have for z's? Negative 6 z's minus 10 of them is negative 16z. And then what about constants? We've got a plus 8 and a plus 8. That's another 16. So plus 16. And in our denominator, we are going to have, we got 3z squared. We're going to subtract 2. So we've got 1 left. So there's a z squared here. Negative 15 z's minus 2 more is negative 17. So negative 17z. And then I've got a 12 and a 4. That's going to give us a 16. You know what? Let's write that 16 a little bit better. So I'm going to write it as 16. Okay, now we're going to try to factor this, right? It may or may not factor, but we have to give it a try. So what we're going to see here is, let's write our parentheses. See what happens, see if we can do this. So 3z squared, the only way that's going to go is 3z and z. And now as it turns out, we can get 2 4s to get that 16. So I'm thinking 4 and 4, a minus and a minus. Let's just see if it works here. 3z squared. Here the outer product is minus 12z, minus 4z is negative 16z, that works, and positive 16. So we got that top factored. Now the bottom is going to factor as a z and a z, but that 16 we're going to get with a 4 and 4 doesn't work. But if we use a 16 and a 1, let's see what happens. Here's 1z and 16z. We can get a 17 out of there. This sign is positive. These two numbers have the same sign, which is that middle minus sign. So we're going to write minus and minus. And what we notice here is that nothing cancels, right? There's nothing common here. So there's nothing to cancel. So let's just claim that this is the simplified form of this original expression here. Number 43 asks us to simplify this 3-term expression on the top trinomial and this trinomial on the bottom. Let's see what we can do with this. The LCD, now because I have more than one term, right, I got 3 on the top, 3 on the bottom, because there's more than just a single term on the top and bottom, I'm not just going to invert multiply, I'm going to use the general procedure. So we get the LCD. The LCD here is, well, what have we got? A 1, an x, and an x squared. A 1, an x, and an x squared. So the LCD is x squared. So what I'm going to do is I'm going to write that x squared here, here, and here, 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 and here, right? You write the LCD next to each original term. It's going to look like this. 2 times x squared plus 1 over x times x squared minus 28 over x squared times x squared over 8 times x squared plus 33 over x times x squared plus 4 over x squared times x squared. So you see that what I did is I took that x squared, I put it here, 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 and here. Now all these denominators should cancel. Let's do that. So nothing cancels here in the first one, so we're going to be left with this 2x squared. And then over here, this x will cancel with one of those 2 here. So that this x will cancel with one of those, leaving us with 1 times x, which is just x. Oh, I didn't change colors again. Let's go back and I'll make that blue. But what we'll have here is this x squared will cancel with that one. So we'll get a minus 28 times 1, which is just minus 28 over, now nothing cancels with the first one, 8x squared. And here, this x will cancel with one of those, right? So let's do that. This x here will cancel with one of those, leaving us with 33x. And then this x squared will cancel with that one. Let's do that. Those cancel, and we're left with this 4 times 1, which is the 4. So we are left with a trinomial over a trinomial, and every time we do fractions, work with fractions, we see if we can reduce this. So let's factor if we can. So let's just write our two parentheses. I'll do it up here at the top. Write our two parentheses, anticipating that we can factor this, and two parentheses, anticipating we can factor the denominator, and see if anything's common and we can cancel. So in the numerator, to get this 2x squared, there's only one way to get that. That's going to be a 2x and an x. Now, we know what to do here, I think. We have a 28. Well, a 28, I don't think a 28 and 1 is going to work. What else? 14 and 2, 7 and 4. Let's use the pair that's closest together, 7 and 4. We'll try that first. And I know that I can't put the 4 here because I would have 2's in common. There's nothing common to begin with. Nothing's going to pop up in common. So if I use 7 and 4, I'm going to have to put the 4 over here and the 7 here. Now that 28 is negative. So I'll put the negative here, right? That'll give me negative 8x. And then the plus here would be plus 7x. Negative 8. You know, that's exactly backwards. I got it backwards, didn't I? So let's erase that. So what I really want is a plus 4 here. That's plus 8, right? Plus 8 and then minus 7. Oh, better guess. Now in the denominator, okay, I already tried this. I mean, what can we use for this 8x squared? We could use 8 and 1 or 4 and 2. I tried the 4 and the 2. I couldn't get anything to work. So when I did try the 8, it did work. I got this. I got 8x plus 1. And then over here, I got the x plus 4, right? What a surprise. I kind of use that idea to factor it, right? Does it work? Just to be sure. Here's the 8x squared. Here's 32x plus x. Is that down here is the 33x. And then 1 times 4 is the 4. And we can see that this x plus 4 is going to cancel with that x plus 4. So what we're going to do is cancel those, divide them out, and we are left with 2x minus 7 over 8x plus 1. So what we're saying now is that this expression here, this original one, can be replaced with this much more compact, more efficient one. Let's give number 45 a try. Now what I'm going to do here is I have only one term in the top, only one term in the bottom, so I'm just going to invert and multiply. So that's going to give us y plus 2 over y plus 4 times, now invert this one, the y squared minus 16 will now go on top, and the y squared minus 4 on the bottom. Now, we're multiplying two fractions together. We know how to do this. Factor everything in sight and cancel any common factors. This is already common. We can factor this, right? Difference of two squares, difference of two squares. So let's do it. So we're going to get y plus 2 over y plus 4 times, okay, we get these conjugates. Y and y, 4 and 4, one's plus, one's minus. And in the denominator, what do you know? We'll get y and y, 2 and 2, one's plus, one's minus. And now we can see we've got some common factors here. That x plus 4 will go with that one, that y plus 2 with that one. So we are going to be left, let's go ahead and do that. Y plus 4 goes with y plus 4, y plus 2 with y plus 2, and we're left with a 1 times y minus 4. So we are left with a y minus 4 on the top, and on the bottom, 1 times 1 times y minus 2, which is y minus 2, and we are done.